Telling time means looking at a clock, determining the hour, determining the minutes, and combining the two. There are two main types of clocks, digital clocks and analog clocks. Digital clocks just use numbers to tell time, while analog clocks use the numbers, a shorthand to tell the hours, and 60 dashes to tell the minutes with a longhand for the minutes as well. There are 60 dashes on a clock because there are 60 minutes in an hour. For this video, we're just going to be using analog clocks. The two hands of a clock tell time by the hour and the minute. Now, students often confuse which hand tells the hour and which hand tells the minute. The shorthand tells the hour and the longhand tells the minute. By calling these two hands the shorthand and the longhand instead of the hour hand and the minute hand, you can better remember which hand tells which. The hour is determined by looking at what number the shorthand is pointing to. So here, the shorthand is pointing directly to the 5, so I know it's 5 o'clock. Now there are many times when the shorthand isn't pointing directly to a number, and students often make the mistake of choosing which number the shorthand is closest to. Now this can work sometimes, but not all the time. So right here, the shorthand is just a little bit past the 5. So I would say it's 5 o'clock because that's what it's closest to. And that would be right. But if I moved it a little closer to the 6, and then I said it's 6 o'clock, that would be wrong because though the shorthand's closest to the 6, it's still 5 o'clock. It's not 6 yet. When trying to tell time, it's better to think about the position of the shorthand to the number. Now, right here, we have the shorthand just past the 5. So I would say it's a little bit past 5, or it's just past 5. Now, the shorthand is closer to the 6, so I'd say it's about 6 o'clock, or it's almost 6. Now, if the shorthand is right in between them, you can say it's halfway between 5 and 6, or it's half between 5 and 6. The minutes are determined by looking at which dash the longhand is pointing to. There are 60 dashes, and each dash represents 1 minute. Now, a common mistake that students can make when trying to determine which minute dash the longhand is pointing to is thinking that the numbers for hours represent the time in minutes. For example, if I was trying to figure out what minutes it is, I would say it's been 2 minutes because the longhand is pointing to the 2. However, this is incorrect. Minute dashes are in groups of 5, and the numbers that represent the hours show how many sets of 5 dashes there are. So here I have my model clock made out of different colored counters, and I have them separated by sets of 5 counters. 1, 2, 3, 4, 5. Now if I want to find out how many counters I have in all, I can count them by ones, which could take a really long time, or I can count them by 5s, which is what I'm going to do. So I have 5 here, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. I have 60 counters, just like there's 60 dashes or 60 minutes on a clock. Now I want to see how many sets of 5 counters I have. So I'm going to start here. That's 5 counters, so that's 1 set of 5, and then here I have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 sets of 5 counters. Now something you may notice is that these numbers look a lot like the numbers that represent the hours on a clock. But these numbers also represent the sets of 5 counters or 5 minutes we have. For example, if I have my longhand here, if it's pointed at the 2, I know that I have 2 sets of 5 counters. So if I want to find out how many counters there are, I can count by 5s. So 5, 10. There are 10 counters, or 10 minutes have passed. Now something you may have noticed is that instead of counting by 5s each time, you can actually just multiply the number of counters in a set, which is 5, times the number of sets. So if I have my long hand pointed at 4, instead of counting by 5s, I can just multiply 5 by 4, which is 20. So I know 20 minutes have passed. I can check this by counting the sets and counting by 5s. So 5, 10, 15, 20. When telling time, it's important to remember that the position of the shorthand depends on the position of the longhand. Let me show you what I mean. So here I have my clock, and I can tell it's 8 o'clock because the shorthand is pointing directly at the 8, the new hour, and the longhand is pointing directly at the 12, which 12 times 5 is 60, so it's at 60 minutes. Now 60 is also the start of a new hour, which is why you see that 0 there. Because if I move my hand over to the next minute, it would be 8:01, which is the start of that new cycle. We're back at 1. Now if I move my long hand to the 30, which 30 is half of that 60 minutes in an hour, you'll see that the hour hand moves halfway between the 8 and the 9. If I move the long hand to 55, which is close to the start of a new hour, you'll see that the shorthand moves close to the new hour, 9. If I move the long hand to 5 minutes past 9, which is still pretty close to that new hour, you'll see that the shorthand moves just a little past the 9 and still really close to that new hour, 9. So whatever the longhand does affects what the shorthand does. Thanks for watching. I hope you enjoyed it and learned a lot about telling time. For more practice in telling time, you can go to the 2 sites below. At this first site, you can practice telling time by using the longhand to move the shorthand to the right hour and telling time in AM and PM. At the second site, there's a quiz and 5 different games that you can use to practice telling time, setting time, or matching time. Well, that's all, folks. Bye!